So it's been an eventful week as far as sports betting goes, if anyone's following the World Cup. There's been a number of incidents with organizations like DraftKings where there's been credential stuffing, account takeover, hundreds of thousands of dollars being siphoned out of accounts. Not fun stuff, but there's good news. Unlike in Qatar, here in Vegas, we can drown our sorrows in beer. So that is a plus. And with that, I will say that there is hope. When you look at organizations like the Department of Defense, just last week they published their course of action, a framework around how to secure an environment going forward, and they require all of their entities to support that and adopt that by 2027. And at the backbone of it is zero trust, which has become a bit of a buzzword. Zero trust is more than a product. Zero trust is really all about organizational change, cultural change, process. And what you'll see with Zscaler is that we've been doing zero trust for 15 plus years. We built the world's first cloud-native zero trust exchange back in 2007 and have continued to scale that, make it more performant, more secure, more intelligent, and it keeps adding additional workloads to it as well. So with that being said, if you're familiar with Zscaler, you'll probably think, okay, the Department of Defense, they built the whole course of action around 7 pillars: users, apps and workloads. They look at the data analytics network, and the overall picture of those 7 pillars then aligns really closely with what Zscaler has been doing for these 15 years. So to take it a step forward, you know, your traditional castle and moat security, think of hub and spoke networks. You build out your mesh network. You have routable networks. You have connections. Sure, you have firewalls. You have VPNs. But there's opportunity for lateral movement within those networks. Zscaler is predicated on the idea that we have the Zero Trust Exchange, which is a broker, and it's really built on 3 principles. It's the fact that we decouple applications from the network, meaning that when a connection is made, it's through the broker. There is no routable network that can be exploited. Number 2, what we are doing as well is obscuring IP addresses. So you can't attack what you can't see. We'll hide IP addresses of your assets behind our exchange, and as a result, the attack surface is greatly reduced. And number 3, it's a proxy. It's an inline architecture, which means that there is SSL inspection. And with today's network traffic, you'll see 80+% of traffic is encrypted. So having an inline architecture that is able to perform SSL inspection is critical. And we perform all this. Historically, you'll be familiar with Zscaler for Users. That was where we started, and very strong, and we continue to invest in that area. But it's become clear that traffic connectivity is expanded beyond users. Workloads, point-to-point workloads, user-to-workloads, APIs, they have become predominant as far as the backbone of an organization is. And Zscaler for IoT and OT. So looking at operational technology, device sensors. These 3 pillars are what make up the Zscaler Zero Trust Exchange. So what we'll do from here is really focus on, with this being more of a cloud-oriented event, we're going to focus on the Zscaler for workloads in particular. It's an area we've been investing in and growing quite aggressively over the last couple of years. So you can think of workload as a continuum. You have, on the left side here, a build, which is more out-of-band, API connectivity, and then through the farther side of the continuum is your security that you're running in line. And this is where the proxy comes into play. So across that continuum, you need to secure the whole thing in order to have meaningful results. And what we have introduced is a posture control product. And posture control is, from a Gartner standpoint, you'll hear it described as CNAPP. It's a cloud-native application protection platform. And it's really rolling up the idea of having your cloud security posture management. So looking at your control plane within AWS, and understanding how S3 buckets are configured, Lambda functions, how EC2 instances are exposed, getting into entitlement management, so understanding what type of roles are attached to those Lambda functions or those EC2 instances. Do they grant elevated privileges that can be exploited for lateral movement? And then going higher into the stack is the cloud workload protection platform. And so that makes up our posture control. And when you think about the workload exposure scanning, think about looking at vulnerabilities, CVSS scores, CVE exploits, and getting a lay of the land from that standpoint. And then tying that back as well to what type of data you have. These environments are accessed. Are they public? Are they private? So that's more on the build secure side. When you look at, okay, inline, real time, when you get into the run secure, workload communications is a product set that we've built that will take workloads that are connecting to the internet. It will secure workloads that are connecting to other workloads. And it will do so by leveraging the zero trust exchange that I mentioned earlier and adheres with those principles around decoupling applications from networks. So what we're going to do now is dive in from the build secure side on posture control. So everyone that's running the cloud, you know that it allows you to move faster. And there's a lot of power in being able to do things in an automated fashion, roll them out quickly. And the power of that is enabling the business, coming up with the ability to expand and scale quickly. However, it flies in the face of security paradigms. Security for years has been more of a review process. You take in a request, you are able to vet it out through architectural governance, and then give an approval or go back through that process until the new project is deemed to be secure. When you have the ability to democratize assets through cloud and the speed at which those assets are provisioned, a lot of that process starts to break down. On top of that, you have more and more feeds. You have SEMs, you have CMs, you have CSPMs. There are feeds of events coming in from everywhere. So you run into the idea of alert fatigue, which is problematic from the standpoint that it cripples you from being able to see what is the signal from the noise within an environment. So to give an example of how we prioritize what is an actual risk from what is noise, we'll use an example of just a simple EC2 instance. It's running an application. That application has a vulnerability, a CVE, that's been identified. The CVSS score, 9.2. Now, that sounds like, okay, this is a high-risk item. But as we all know, that's in a bubble. That's a vacuum. What really matters is that EC2 instance connected publicly? Is that EC2 instance have the ability to get to EBS blocks or S3 storage that has sensitive data? And lastly, when you think about entitlement management, does that instance have an IAM role? This is oftentimes what will allow toxic combinations to occur, which will lead to privilege escalation and all sorts of lateral movement opportunities within a cloud environment. So we'll track all of those different factors and peel back layers of the onion. So this is how you can think of it. You start out with 10,000 assets, that CVE score. Well, you go and you look at where is that vulnerability exists on those assets, which ones are externally accessible, and then finally, which ones have elevated permissions. And from there, then you're able to prioritize and have a starting point for incident response. Looking at that visually within our posture control product, we have the graphical timeline view here on the bottom left that really builds an incident response campaign, where you think about at what point did this asset become publicly exposed to the internet? When was that security group modified? What was the impact of that modification? Then from there, was there any sort of vulnerable application running on that asset that is now exposed publicly? And then you can continue to build that story as you start to think about, okay, it's vulnerable, it's exposed to the internet, it has a John Smith, in this case, role attached to that asset so that it could then potentially access S3, it could access Lambda, it could escape the VPC even if you have the right privileges on that role attached. And to top it off, then we'll also look at the data that this asset has access to. And bringing all of that together, you can form a risk profile. So there's, you guys familiar with shift left? It's more around the idea of getting into the supply chain for your software. So we're scanning as well your IDEs, looking at your version control systems, GitHub, GitLab, CI/CD, Jenkins, GitHub Actions, going and diving into those platforms so that you can identify infrastructure as code that might potentially perpetuate any sort of vulnerable configuration you have that will be pushed out to your environments. So nip it in the bud. And then lastly, on posture control, what's critical from a compliance standpoint is that you're mapping these findings back to a framework or a baseline. So think of terms of PCI, NIST, the CIS, just being able to map this and track progress as you remediate issues over time to show that, hey, we started out with vulnerabilities that map into our NIST. We're trying to get compliant. We want to be able to show and produce results to auditors. This is a critical piece of what posture control does as well, beyond incident response and investigation. So as I mentioned, continuum of security is critical. Not just looking at, hey, what can we do with APIs and connecting out of band to identify posture, but really getting into what are the workloads that are running? What is the actual real-time data being exchanged? And that's part of our workload communication. So within workload communications, it's the idea that we're going to run secure. In order to really illustrate the power of what we're doing in workload communications, we're going to take a step back and talk about legacy network. You're familiar with building out a mesh. You start out with your data centers. You start to add clouds, VPCs. Maybe those VPCs have direct connects back to your data centers. Maybe they're peering VPCs between each other. Whatever the case is, you're going to stand up a number of virtual firewalls, a number of VPNs. You have more cost, you have more attack surface, and it creates a routable network so that if there's an exploit in a DC or in a VPC, the threat actor is more than likely going to be able to find a way to traverse that network through a routable network access. Just diving into a certain region, it's the transit gateway. When you think of the topology that is oftentimes deployed, we won't go through every detail. Probably looks pretty familiar to everyone, but you end up with this complex routable environment that is ripe for being exploited. So what does Zscaler do? This is where the Zero Trust Exchange I hit on earlier is put into action. Here, rather than having a routable network, we establish secure encrypted microtunnels between your data center to the various cloud providers that you have. And within those cloud providers, you'll have what we call connectors that will establish inside-out connections. So this is why I mentioned earlier you don't have IPs that are published on the internet, and you're reducing your attack surface. And this is how you decouple application access from network access. If you zoom in on a particular region, you'll have the app connectors, which tends to be a destination, and the cloud connector, which is your source. These connections, as I mentioned, they establish a microtunnel through our Zero Trust Exchange, which, by the way, is doing over 250 billion transactions a day, blocking 140 million plus unique threats every day. 0 days, suspicious behavior. It's the cloud community effect that we get. And the net result is you're able to eliminate the routable network. You're able to eliminate the cost of multiple virtual firewalls and the complexity that goes along with that. Not to mention, it's great for use cases like merger and acquisition. You don't have to worry about overlapping IP address topologies in this. If you have overlapping IPs, it's all obscured. So this is wrapping it up here. I usually look at it as a phased approach. You can start out very simply with, hey, I want to get my workloads out to the internet, and we can run that through the Zero Trust Exchange, look for malware, look for exploits, command and control. Then you can move on to workload clouds. And then you can even get into micro-segmentation, we're actually going into one cloud provider and saying, I want to actually segment my VPCs and have them communicate through the Zero Trust Exchange as well. So there's a way to crawl, walk, and run as you progress through the journey of Zero Trust. And that brings it back full picture. So this is how we bring these pieces together. And what we're doing as a company is building meaningful integration between posture control and workload communication. So there's a signal exchange and a feedback loop between your real-time workloads and more of your cloud posture control management, the CNAPP side of the house. That's what we have for today. I'm David Sedgwick. Please come to booth 118. You can dive into demos there, and we can talk through detailed architectures you guys have. Thank you for the time today.